Let's take a look at this question from HC Verma Concepts of Physics. It's from Newton's Laws of Motion. We're given two blocks over here, one of mass m1 and one of mass m2. The block, they're situated on this level ground over here. There's a pulley, everything is frictionless. Assume the pulley is massless. And there's a force being applied on m1 in this direction, and it's got magnitude m2g divided by 2. G is the force of gravity. And then there's this block m2 over here as well, and we're asked to find the acceleration of m1, and of course we can use the variables like m2, m1, etc. So let's try to find that. The first thing to notice is that there will be a gravitational force on m2, so it's going to be going downwards, right? And it's going to have magnitude m2g, right? It's just this mass times the force of gravity, and the same force is going to be transmitted to m1 over here. It's going to be exerted on m1 by m2, so we can write that over here. What are the other forces acting on m1? We can make a free body diagram. So just treat this here as m1. So first there's going to be the force of gravity. So that's going to be the force of gravity, which will be m1g. And I've drawn it pretty badly, but imagine this is vertically up. This will be the normal force, which will also have magnitude m1g. So these will cancel out. Then we've got this over here, which is m2g2 over 2. And then over here we've got this, which is just m2g, right? So this force and this force will cancel out, and the net force, the final force, is going to be m2g plus negative m2g over 2, because that's in the other direction, right? So the net force is going to be m2g over 2 in the rightwards direction. That's the force. We want to find the acceleration of m1. Remember that we can't just, so if this is the force, this is the net force. To get the acceleration, we need to divide by the mass. But what mass do we divide by? It's not enough to just divide by m1, because m2 is also going to be moving, right? Like the entire system is going to be moving at some acceleration. There's going to be some acceleration on the entire thing. So this force, this net force, is applied to everything over here. And so the acceleration is going to be m2g over 2 divided by the total mass of the system, which is m1 plus m2, and this is simplified to just m2g divided by 2 times m1 plus m2, and with that we're done. That's it.